Hello and welcome, I'm your Code Monkey. In this lecture, we're going to start with the absolute basics, learning exactly what is dots and what does it do. Okay, so before we begin building the game and writing some code, let's first cover the absolute basics of dots, just so we're all on the same page. Now, dots or Unity dots, that stands for the Data-Oriented Technology Stack. This is a set of technologies that Unity built, which are based on some very specific rules, like being data-oriented, and by following those rules, it can provide you an insane amount of performance. This was a very ambitious toolset. They started working on it back in 2017 and only very recently became production ready. The benefits it can provide are definitely immense, but they do require a different way of thinking. So my goal over here in this course is to teach you that different way of thinking so you can properly use this insanely powerful tool. Like the name implies, this is a technology stack, meaning it's not just one thing. It is actually composed of three separate technologies. The three main ones are the Entity Component System, the Job System, and the Burst Compiler. And out of those, the Entity Component System by itself is composed of three things. You have entities, you have components, and you have systems. Now, entities are basically just an identifier. Entities by themselves have no data, no logic, nothing at all. They're really just a number and nothing else. Then on those entities, you can attach components. And components, this is what actually stores the data, like for example, some kind of movement speed. And finally, you have systems. And systems, this is what runs logic on entities that have certain components. Like for example, if you have some kind of unit mover system, which looks for entities that have both a local transform and a move speed component, the system will cycle through all entities that match those components, that have the same components that match the entity query, and then use the data from those components, like the speed inside move speed and the position inside transform. It uses those to do some kind of transformation on that data. So for example, in this case, maybe it grabs some kind of float movement speed from this component and uses it to modify the position on the local transform component. So this is the core of ECS. You've got entities which are just identifiers, components which actually holds data, and then systems which run logic on that data. Another very important part of ECS is actually memory management. Although you don't need to do this yourself, it's all handled in the background, but it explains why it's so fast. So the reason why ECS is so insanely fast is because in the background, Unity is making sure that all the memory is all tightly packed. All of the components, like this is one component type, this is another one, this is another one, instead of being split all over across memory, instead of that, it is all nicely, tightly packed. All that data is right next to each other, which makes it insanely fast for the CPU to access. Compared to, for example, game objects, since it follows an object-oriented design, you have tons of pointers to different positions in memory, so everything is very scattered, which makes for very slow CPU access. You have, for example, a game object over here, which accesses a position memory for some kind of move speed, and it's over here, so the CPU has to jump here, then has to run some kind of functions that is on a different component, so it jumps over here. Then it accesses some kind of other game object reference, so it jumps over here, and so on. So this process of jumping all over the place in memory, this one is quite time consuming, it is quite inefficient. Whereas over here with ECS, all of the components have their memory packed tightly together. So when a system goes to do some logic on some components, the system's literally just jumping from component to component. So just one to the other one, that is so much faster than jumping randomly around in memory. Also note the specific separation between the components that just hold data and the systems which just run logic on that data. ECS is all about a data-oriented design as opposed to object-oriented programming that you're probably familiar with. In object-oriented programming, you define some kind of object and that object has both data and logic. This is what leads to lots of pointers pointing to different positions in memory. Whereas in ECS, with a data-oriented design, with this you have a separation between those two, which again leads to faster, more tightly packed memory. So entities are just identifiers, components just hold data, and systems just run logic on some data. That's it. This also means that your code can actually be more modular. For example, if you have this kind of system, let's say this is a unit mover system, this system will move any entity that has a local transform and a move speed component. Importantly, it does not matter what that entity represents. It doesn't matter if this represents a single unit, or a tank, or a building, or a bullet. If the entity has these two components, if so, then the system is going to run the same logic on it. The system does not care what exactly the entity represents. It just runs the exact same logic on all entities that have all of the components that match the query. We're going to see this in the course, how, for example, we're going to create a find target system. That system will work for both the player finding targets of the zombies and work for the zombies finding targets of the player. So that makes the entity component system. The second main part of dots is the job system. This one is all about writing insanely fast multi-threaded code, meaning run code on multiple threads, multiple cores all at once. As you might know, CPUs nowadays have lots of cores. However, a lot of game code usually only runs on one core, just one thread. So all the other cores, they're just wasting time doing absolutely nothing. Based on that, as you can imagine, you can gain an insane amount of performance essentially for free by just using those other cores. Now, the reason why a lot of game code uses only one core is because writing multi-threaded code is usually extremely difficult. You can easily get a ton of errors that are extremely difficult to debug. The job system helps solve that by adding a ton of safety nets and a bunch of limitations, which in itself makes it much easier to write multi-threaded code. You simply define some jobs and queue them up, then Unity handles all of the complex logic of dependencies and figuring out which thread should work on what job. So job system helps you take advantage of the CPU and all its cores as much as possible. You can take the exact same code and literally run it in double or sometimes 100 times faster, because instead of running it all sequentially on just one thread, you're going to split it across multiple threads. And the third main part of dots is the burst compiler. Now this one is almost a piece of magic. It is a special compiler that Unity built which is all about performance. Just by enabling it, you can literally get 100x performance improvements in some scenarios. It is truly an insane piece of tech. However, in order to get those massive speedups, it has a bunch of limitations. The main one has to do with how your code needs to be data-oriented as opposed to object-oriented. It needs that in order to receive those benefits. These limitations are something we're going to learn about in detail in future lectures, specifically the difference between value types and reference types. So you can't just make every code burst compatible by default, but if you keep in mind those limitations, then the results you can get by just adding a simple attribute to your code is really quite insane. When you combine burst with the job system, your code will not only run super fast, but run super fast on all cores all at once. Then when combined with the NT component system, which again is all about data-oriented design, when you use all three, you get some really insane results. This right here, this is an actual example that we're going to build in a future lecture. You can absolutely have some normal code that takes 9 milliseconds to execute, running that just on a single thread, just on the main thread. Then you can use that code and convert it to use a job, and that same code all of a sudden runs at 0.29 milliseconds. And then you take that same job and you just apply the burst compatible attribute, and with that, that exact same code is running on 0.035 milliseconds. So you go all the way from 9 milliseconds to 0.35. That is a 260x faster performance improvement. You get all that just by using jobs and the burst compiler. Now this sounds crazy, making the exact same code 260 times faster. That does sound insane, but that is absolutely real. That is how powerful dots can be, and it is why you should definitely learn how to use this tech. Now these are the three main components of dots, but dots also is composed of a bunch more packages. For example, you've got Unity Physics. This is an extremely performant physics system that was built specifically for ECS. Then you've got the collections package. This one includes a bunch of data-oriented collection, meaning things like lists and arrays, but that were made to be data-oriented instead of object-oriented, meaning they work with jobs and burst. Then you've got the mathematics library. This is another package that was built specifically for use with burst, so it handles all kind of math operations, all of them extremely performant. Then entities graphics, this is how you can render entities. It's also super performant and works with both URP and AGRP. And netcode for entities, this is their networking library meant for multiplayer games using dots for some super high fast-paced multiplayer. All of this together is what is known as dots, or the data-oriented technology stack. And one very crucial thing about dots is how each of these main parts, each of these can work by themselves. You don't have to use them all. For example, you can just use the job system and the burst compiler. You can just use those two without using entities at all. Or you can just use entities without using jobs or burst. Basically, these three tools, these are distinct separate tools by themselves. Although, of course, when combined, that's when you get some truly insane results. And another extremely crucial thing about dots is always remember that dots is just a tool, and it's a tool that can be combined alongside game objects. So you can and you should mix and match both game objects and dots. You don't have to go full 100% one or the other. You can use the right tool to solve the right problem. For example, in this course, we are going to be making an RTS game. RTS games are all about tons of units and lots of complex logic. So in this case, for this game, we are indeed going to be making this game, let's say about 80% using dots and about 20% using game objects. We're mostly going to be using game objects for the UI and some general manager scripts. However, you could absolutely do the opposite. If you were making some kind of action-adventure game, you could definitely use game objects for about 80% of your gameplay and use dots just for the 20% that is really performance heavy. One of the main benefits of dots is indeed performance. So you can build your games using mostly game objects. Do it just like you're used to building any games. And then when you use the profiler and find some hotspots in your game, you can use dots just to solve those particular hotspots. And again, when it comes to dots, you can either use entities plus job system plus burst, or you can perhaps solve those hotspots by just using the job system and burst without using entities. So you can get a ton of benefits by just refactoring some piece of code without having to completely re-architecture your entire game. So always keep this in mind, they can work together, dots and game objects. Dots is really powerful because of that. It does not require you to give up all your knowledge of game objects. Dots is just another tool in your toolbox. It is not a replacement for game objects. It is a tool that is extremely good at what it does, And as with any tool, it is up to you as the developer to figure out when and where to use that tool. Now, in terms of learning all about dots, here in this course, I won't teach you everything needed to build this game. I will introduce concepts like entities, systems, and jobs. I will introduce those as we need them to build the game. This is a very practical step-by-step course. So instead of learning everything all at once, learning just the theory on all the concepts, instead of that, we are going to learn them as we use them. But if you want to get an overview of the entire tool stack, there's two excellent sources that I recommend. The first one is Unity's official ebook. This is an excellent free ebook that has 50 pages. It is really detailed. It talks a lot about dots. Specifically, this is a high-level overview on the theory behind dots, how it works, all of the various components, why it's important, how exactly it makes the code faster, and so on. So this is very much a high-level overview as opposed to a technical guide with very specific implementation details. And for a mix of both high-level and technical, you can go watch my tutorial on dots. In there, I focus on teaching how to start using all the technical parts that make up dots. So that video is a great, very condensed way of learning the entirety of dots. Like I said, in this course, I will teach you everything, all of the components of dots, step by step, as we need them. So you don't necessarily have to go through these two resources. Personally, if I was you, I would go through both those, just because, personally, I like first learning a high-level overview and then learning the more practical aspects. But either way works. You can either make a quick pause to go through these resources or just continue following the course. Either way works, up to you. Okay, so now that we know exactly what is dots and what does it do, now it's time to start actually using it. So let's begin creating our project and installing packages in the next lecture.